Welcome to Physics 30 Prep Fast Track, Lesson 11, Two-Dimensional Motion. The second type of two-dimensional problem that we'll look at is when you kick a ball or hit a golf ball or any object that's thrown from a level field and lands at the same height. Lands a certain distance away at the same height. So the given information will often be the initial speed and the angle of elevation. So you're kicking a ball, you're not kicking it horizontally, you're not kicking it vertically, but you're kicking it at some angle from the horizontal. And the three things that we can usually ask are, how far will it go? That is the vertical or the horizontal distance. How high will it go? That's the maximum vertical displacement. And of course, how long will it remain in the air, the hang time or the time of flight. So as before, the horizontal motion is uniform, so we use v is equal to distance over time, or we can change that to d is equal to v times t. The vertical motion is influenced by gravity, so we use one of our four kinematic formulas and use g is equal to negative 9.81 meters per second squared. Now, with this example, the common component is the time of flight. But this is a little more complex because initially the velocity has non-zero vertical and horizontal. So with the previous example, when the ball rolled off the shelf, the initial vertical velocity was 0, and that made things a little bit easier. Now it's not 0, so it does make things a little more complicated. We have both horizontal and vertical initial movement, and so we have to make sure we keep that in mind in the process. So these must be determined before the unknown quantities can be found. So the process is found in the following example. So if the ball is thrown with a velocity of 15 meters per second and an angle of 35 degrees, how high, how far, or sorry, how long, or what is the time of flight, and how far will the ball travel horizontally? So the first step is to resolve the initial velocity into the horizontal and vertical components. Once we know these, then we can start to solve the problem. So initially, horizontally, we know nothing. We know nothing about the horizontal velocity. We know nothing about the displacement or the time of flight. Vertically, the only thing we know is that acceleration is 9.81. Another key thing that we do know, though, is that the time, whatever it is over on the horizontal side, is equal to the time on the vertical side. That's the tie that binds, all right, that keeps these two things together. So what we need to do is use trigonometry and take our initial velocity of 15 meters per second. This ball is being thrown at an angle of 35 degrees with a velocity of 15 meters per second. And so what we need to do is find out what is the vertical component, what is the horizontal component. And so those vertical and horizontal components need to be found using trigonometry. So the sine of 35 is opposite over hypotenuse. And so the opposite side, or in other words the vertical component of that 15, is equal to the hypotenuse, 15 times the sine of theta. And the vertical v, as we call it, is equal to 15 sine 35, or 8.604. What that means is that this ball is rising vertically. When it leaves the thrower's hand, it's rising at 8.604 meters per second vertically. Now the horizontal component is found using the same idea, only instead of the sine we use the cosine. So cosine is adjacent or horizontal divided by hypotenuse, which is 15. So the adjacent is equal to the hypotenuse times the cosine of theta, and 15 times the cosine of 35 is 12.287. So horizontally, it's traveling at 12.287. Now we also know that vertically, it's going to change because of gravity, 9.81. Horizontally, it's not going to change. It's going to remain at a constant 12.287 meters per second. So to find the distance horizontally, we could figure out the time and multiply by our 12.287. So that could help us to solve for C. So keeping that in mind. Anyways, we can find all three unknowns. That is, we can find how high the ball will travel, what's the time of flight, and how far the ball will travel horizontally. So let's look at each of those three solutions. The first question is, how high will the ball travel? Now, one of the things that we should understand about this is that when the ball is rising, it has an initial velocity, as we determined previously, of 8.604 meters per second. But as it rises, gravity pulls down. And at the top of its parabolic path, the velocity at the very top of its path is 0 vertically just for an instant. So initially it'll have a certain velocity, 8.604, but as the object rises it will slowly come to a stop vertically, and then of course it'll start coming back down. And in fact, when it hits the ground, it'll be going 8.604 meters per second downward. But to find the displacement vertically, that is the maximum displacement, we solve for d, and we know that acceleration is 9.81. We know that the final velocity is 0. We know the initial velocity is 8.64. So it's fairly easy to choose an equation, choose the one without time, and you have Vf squared equals Vi squared plus 2AD. Manipulate that formula. Subtract Vi squared from both sides. Divide both sides by 2A, and you're left with d. Then you do your substitution, making sure that you're careful that these little squareds don't get forgotten. If you forget to square that, of course, you're going to get a much different answer. So 0 minus 8.604 squared divided by 2 times the acceleration of gravity gives you a displacement of 3.773 meters. It's positive because it's up. And there's your answer. There's your maximum height right there. Okay, so fairly straightforward in finding out how high it goes. Once you've done the initial work and taken that 15 meters per second at 35 degrees and resolved it into its two components. So question B is, what is the time of flight? Well, there's a couple of ways we can do this, but I'll show you one method, and that is if we said that the initial vertical velocity when the ball left was 8.604, and we determined that using trigonometry previously. When it comes down, because of symmetry, Vf is going to be negative 8.604. This change in velocity is caused by gravity, and of course we can use a simple algebraic expression. A is equal to Vf minus Vi over t. Isolate that for t by just dividing both sides by A and multiplying both sides by t, and you get t is equal to Vf minus Vi over A. Then, by substitution, and be careful here, many students have said 8.604 minus 8.604 must be 0. It's not 0, it's about minus 17.2 or so. All right, so 17.2 divided by 9.81 gives you a time of flight of about 1.75 seconds. So now we know the time of flight. And as we said earlier, since we know the time of flight and we also know the horizontal velocity initially, and it doesn't change, we can now figure out what the horizontal displacement is. So we've done the maximum height, we've done the time of flight, now we just need to find the horizontal displacement. So how far will the ball travel horizontally? As I said, d is equal to v times t, and therefore since d is 12.287 since the speed is 12.287 meters per second, we just calculated what the time was, 1.754 seconds. The result is 21.55 meters. And that is the horizontal distance that the object would undergo. All right, so we figured out the maximum height, time of flight, horizontal distance. How far, how high, how long. And just to review this just a little bit, by resolving the initial velocity into its perpendicular components, we were able to find the maximum height, the maximum distance, and the time of flight. So you have to make sure that when you're given an object that is projected into the air at an angle. The first thing you'll generally have to do is resolve that initial vector, 15 meters per second in this case, into its two components, because these two components are independent of each other and must be dealt with separately, as we separated them using the little cross, into their two components. The only thing that is common between the two is the time of flight. Now you'll have a few chances to practice this once we finish the third type of example.